Hello everyone. What does IPO mean to you? I'm sure you can remember how to draw up your IPO tables as part of your practical assessment task. In the last lesson, we saw that it's wise to make an IPO table for every algorithm in your program, using a table like this. There will be columns for input, processing, and output. Remember to add a heading and a short summary sentence about the IPO table. We've been working through all the PAT steps. So far, we've covered everything that has to be done in Phase 1. And in Phase 2, we've already learned about a number of steps, from program specifications to algorithms and making IPO tables. I wish Thabo would arrive now. I had planned to go over data storage in IPO tables.
Sorry to keep you waiting, Mr. Kumano.
I hope you weren't having second thoughts about IPO tables.
I wish I could ignore them, but no. I actually practiced one or two. They make it easier to see exactly what each module is going to do.
Glad to hear it, Thabo. Now let's see how to store data in your IPO table. By the end of this lesson, you should be able to identify primitive, structured, and abstract data types to use for temporary storage. Identify file types and structures to use for permanent storage. And indicate where data validation, error checking, and exception handling are required. Think back to the IPO table we made. Once you've created your IPO table and stated what is available, and completed your input, processing, and output columns, you need to look more closely at the data you'll be storing, either temporarily or permanently. We'll do this in the next lesson. Let's start with the temporary storage. You are ready to identify data types. You must identify primitive, structured, and abstract data types to be used for temporary storage in RAM. You remember these types of data, right?
Yes, I know that any variables I use will be of a primitive data type, like integers, real numbers, strings, and Boolean data, which is a true or false value.
Yes, and the big difference between primitive and structured is that structured data types are more complex. They include arrays of a number of elements of one primitive data type and records which have a number of elements, each of which can be of a different data type. I wonder if you remember abstract data types.
They are the classes we use to create objects that are predefined by the class. They consist of storage fields and definitions of how the object must behave.
That's right. We have primitive data types that include variables that have data types like integer, real, string, and Boolean. Structured data types of arrays which are an indexed list of data items or elements of the same data type. Records, which is a complex data structure consisting of a number of fields or elements, each of which can be of a different data type. As well as abstract data types, like predefined objects which have storage fields and methods or behaviors. I've got a few examples to show you. Here's an array of data type integers. The index here is 1, 2, 3, and so on. This shows the position of the element in the array. Each element is of the same data type as all the other elements in the example. They are all integers. This record has 4 fields or elements, but here different data types are used: string, integer, and Boolean. We can have an array of records where each element of the array is of the same data type, a record data type, but each record has different data types. Similarly, we can have an array of arrays or an array of objects. Let's look at an object. An object consists of a number of fields of different data types and the methods or behaviors which will allow a program to access the object. Take an object admin, for instance. An object admin will be created and placed in RAM as the program opens. Then it will be destroyed or removed from RAM when the program closes so that the space it occupied is freed. Why would we need an object admin?
Well, we have to store the admin password somewhere.
Do you think we have to store it in an object admin? Why can't we store it in the program code or in a database or text file? Can the administrator access the program code?
No. If you store the admin password in a program code, only the programmer can change it. If the administrator changes it, you can't store it back in the program code.
What about storing it in a text file?
Anyone can access a text file with Notepad.
That's correct. It's almost impossible to control access to a text file. We could perhaps store it in its own database table, but it isn't logical to have a whole table for only one record, with only one field. If you store the admin password in an object admin, you can easily control access to it. Any idea how?
You can have a Boolean field in the object and write a method to set the value to false when a player logs in. Then he's denied access.
Correct. Take this example. Here we have a Boolean field in the object. A method was written to set the value to false. When a player logs in, if it's false, he's denied access.
If an administrator logs in, you set the rights to true, then he gets access.
That's right, Thabo. Here we can see the fields, as well as the methods in our storage object. An object can also use methods for encoding and decoding the administrator's password. If we call the encrypt method in our program, it will provide us with a string of characters we can write into a text file. Even if someone finds and opens the file, they will not be able to use those characters to log in as the administrator. When the program opens, we just have to read the text file and call the decrypt method to change it back to the correct password and store it in the object. Once you've identified the data types you'll use, you have to add them to the IPO table. Let's look at the register event again. Every data type for data used in the event must be identified and indicated. In the input column, the grade, first name, surname, and password are all strings. Do the same with the available grades. We will need to temporarily store the usernames already in the database while the program checks them. We could use an array of records, but as we only need one field from each record, we can store the existing usernames in an array of the string data type. The variables in the processing column, which have not been mentioned in the input or output columns, should be written here, and new user is a string. In the output column, grade and username are also strings. Do not write data types in the column where the processing algorithm is described. Write them in the input and output columns, or add the variable to the available row and fill in the data type there. The programmer will probably want to use either the username or the first name in several places in the program.
Like when he welcomes the user or encourages the user. Well done, Thabo, or welcome back, Thabo.
Or don't allow Thabo to go to a higher level. His score is too low. Just kidding. Or a learner in grade 10 might do so well, the score will increase if he plays a game at a higher level. There could also be other data related to the player that must be temporarily stored and used in different events. Any idea what this could be?
Which grade the player is in?
Yes, some of this data might be in a database, some in a text file, and some in different non-local variables. It doesn't make sense to open files constantly to retrieve data that is needed. What does make sense is to use an object to store the data in only one place and have methods to change or access the data. Now we said we need an object, admin, to control access to parts of the program, but we can't use that for these details. What kind of object would we need?
A player object?
Yes, an object player is needed with the fields first name, username, and grade, and with methods to get each of the 3 values from the object, and of course to put the values into the fields in the first place. You don't have to show an object player in the IPO table for the register event, because the user is just registering and hasn't started playing yet. But you would need an object player when you write the IPO table for the login event. What else is important when you write the IPO table for a login event?
You'd also have to use another object.
So you were paying attention. We need an object called admin. It would be used to store the admin password and to indicate whether the current user had admin rights or not. If the user has admin rights, he is allowed to add terms and definitions to the database and modify any records. Otherwise, he can't access the database or records. Look at our object admin again. This is very similar to what we saw earlier in the lesson. We call this a class diagram. You will learn more about those in the next lesson. An object created from this class definition will have 2 fields. The private methods can only be used by the object. This means that once the program is written, not even the programmer will be able to call the encrypt and decrypt methods. The public methods can be used by the programmer to call the method for the processing in some program event. The programmer will call setPassword and supply an encrypted password from the text file. The setPassword method will use the decrypt password method and then store the actual password in fpassword. We should name an object that we will need in the available row of all the IPO tables that will use the object. But the way the object's input, output, and processing works must be shown in a separate classes and objects section of your Phase 2 design document. Once you've identified data for temporary storage, you move on to permanent storage. Drawing up the IPO tables should give you a clear idea of what must be stored permanently. You have to identify file types and structures to be used for permanent storage. What types of file must you use in the PAT?
Databases and text files.
Yes, you have to state which of these you will use in the IPO tables. Can you think of examples?
You could store admin password in a text file. And I reckon stuff like grade, first name, username, surname, and password will be stored in the database.
When you create your PAT's IPO tables, make notes in a separate document of what must be stored, as well as the data type for fields in the database. We will look at how to design the database in a later lesson. Save the file as files needed. Use the headings text files and database, like for example, text files. adminpass.txt, which is the file name, encrypted password. username.txt, game history for each user, date, level, type, score, and terms wrong. We could add lines to this file each time the user plays a game and show it to the user if he asks to see his game history. We use the hash character to show the structure or fields of data we need to store. Database. Learners, the name of the table, grade, first name, surname, username, password. These will all be string data types. Terms, term string, correct answer ID, integer. This will allow us to get the correct definition from the definitions table. Definitions, definition string. This brings us to the last step necessary to complete your IPO tables. For your PAT, you have to indicate where and how you will validate data, check for errors, and handle exceptions. The best place to do this is in the IPO table that it relates to. You have to indicate where you will have to validate data, check for errors, and handle exceptions. Validation and error checking must always be done on input provided by the user, and it's sometimes necessary when working with input from or output to a file. Exceptions can occur anywhere in your program.
Exceptions as in the things that might go wrong and prevent your program from working.
Yes, let's look at data validation first. Data validation involves checking that the input is in an acceptable format. Give me a few examples.
Check if the password is the right length. If you ask for an ID number, check if it's exactly 13 characters long, and each character is a digit. Check that the user gives input where he should and doesn't leave a field blank.
If an integer is input, the user should only use digits, and in some cases the number should lie between certain values only. Now let's consider errors. Errors are mistakes made by users. What about keyboard errors? How can they be avoided?
I make a lot of typos, and I get confused when it comes to typing the date. I never know what comes first, the month or the day. It's best to let the user select from a list of options if possible, instead of typing it in.
So you can use components that assist the user. You can also write code that will detect user errors before the input is accepted. Then it informs the user of the mistake and tells the user how to correct it. How would you avoid mouse errors?
I suppose by making sure the user knows what is expected of him. Give him enough information.
See why it's important to verify data, check for errors, and handle exceptions? If you don't, the program can pick up all sorts of problems and it won't work properly.
Should we do this for every IPO table we draw up?
Yes.
Do you have to make a note every time you check the same thing, like the username?
No. Many of the same validation techniques appear in the different IPO tables. If this happens, you can use the same technique in all of them. You don't have to rewrite the whole thing either. Simply write refer to register event table. To indicate where and how you will have to verify data, check for errors, and handle exceptions, insert a row at the bottom of your IPO table. Read through the IPO table and write a brief statement of what must be done. Let's go back to the IPO table for the register event. We know what is in the table, so let's just note some of the things we might have to do. Check that the grade is 10, 11, or 12. Check that both the first name and the surname have been typed in. Check that the password is long enough, and confirm the password. Prevent the program from crashing if the database is already open when a record needs to be added. Now we state what we will do about the possible problems. Note that we say what we are checking in the input column and what the user will see in the output column. These will mainly be error messages. The grades will be offered in a combo box so that the users cannot make spelling mistakes. Select will be the default to prompt the user to choose a grade. The program must check that neither the first name nor the surname is left blank, that the password consists of at least 6 characters, and that the password and confirmation are the same. Exception handling. If the database is open when the program wants to store the data, it will be marked as read-only. This would make the program crash or cause a runtime error. An exception handler using try except will be written to deal with this. It's also possible to write to close the database, but the teacher must be working on the database in MS Access if the program is on the school's network. So the message could say, call the teacher instead. You must draw up an IPO table for each event, as well as for any modules meaning functions and procedures, for which you have written algorithms. Here's the IPO table for the function are_equal. For the modules, the calling event in the program will pass parameters to be used as input. If the module returns a value to the calling event, it is output. Show these in the input and output columns. Show any local variables needed as available. Also, rename the two columns input parameters and output parameters. Remember to add comments under the table heading to summarize what happens in the event. Also add these comments into your programming code for internal documentation. Here's your task for this lesson. Study this IPO table, which contains the algorithm for logging into a program and indicates user input and output. In this scenario, the person logging in can either be a player or the administrator. 1. The available temporary storage structures have not been listed in the available section. Study the processing column to determine available temporary storage structures, then write them down. Remember that objects are also temporary storage structures. 2. Name any files you will need for permanent storage. 3. Explain how selecting a grade assists with data validation. 'By now I hope you have realized that the main thing to refer to when you write your event handling code is your IPO table for each event. The IPO tables are your blueprint or plan for writing the program. Enjoy drawing them up.